Hello. 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 Okay. So we will start with the other SAQs from the 12th chapter. That is we have finished till now the uh, leaf, dicot leaf, monocot leaf, TS differences, and the meristematic tissues that are present in the based on the position. How many meristematic tissues are there in the plant body? That also we have finished, and we have finished the differences between the dicot stem and the monocot stem. Okay, and now we will see the lenticels and the stomatal apparatus, the differences. That question also over. Now we will see the other three questions, that is the most important ones, because that comes there during the secondary growth of the plant body. So that is the secondary growth occurs only in the dicot stems, okay, dicot plants. So how the bark is formed, that means after the secondary growth, how the periderm is going to be formed. Okay, so what is meant by periderm and how the periderm is going to be formed? That is the question. What is meant by periderm? This is the most important one. So before going to say this, I want to draw the diagram so that it's easy. Wait. When we are drawing this during the secondary growth, yesterday also I have shown you the how the lenticels are formed, na? Same thing, but now we are giving the complete labeling part, how the secondary growth occurs. Okay. This is the cambium. Below the cambium is the we can go with the green. Okay, like this, the cells are present, and here now we have to fill up with the other cells. And what is the labeling for this? This is the lenticel. About this, actually, the dead tissue bark will be present. This is the bark. And these are the parenchymatous tissue. These are the parenchymatous tissue. Okay, and this is the cambium, cambial cells. So during the secondary growth, above the endodermis, the cambial cells are called as the cork cambial cells. And below the cork cambium is the periderm. Periderm. Okay, so here what we'll say, sorry, it's not the periderm, it's the secondary cortex. We'll call it as secondary cortex. And the periderm that is formed during the secondary growth is the having the 3 layers in it. It is made up of 3 layers. That is the phellum, phellogen, and phelloderm. Phellum, phellogen, and phelloderm. Okay, so what is meant by phellum, phellogen, and the phelloderm? So the phellum means the cork, otherwise the bark that is formed during the secondary growth. Cork or bark that is formed during the secondary growth outside the cork cambium, that is the cambial tissue. Okay, that is called as the phellum. So this part is called as the phellum. And phellogen. Phellogen means the cambial cells that are going to be making the mini cells during the secondary growth outside the stellar region. Those are called as the phellogen. That is the cork cambium. We can call them as the cork cambium. Okay. And phelloderm. Phelloderm means below the cork cambium, otherwise below the cambial cells, the secondary cortex, the living simple parenchymatous cells which are present above the primary cortex are called as the secondary cortex or phelloderm. So like this, 3 layers, what we can say. So these 3 are the actually the scientific names, what we can say, and in general, what we can say them as the cork or bark, otherwise the cork cambium and the secondary cortex. Okay, so here the periderm means during the secondary growth outside the stellar region, the bark, that is the layers that are formed, are called as the periderm. And this periderm is made up of 3 layers: phellum, phellogen, phelloderm. Okay, phellum. Phellum means the cork, the parenchymatous cells that are present away outside the cork cambial cells are called as, otherwise the cambial cells. Above the cambial cells, the cells which are present are called as the phellum. And this phellum is usually what we'll consider it as the cork, otherwise the bark tissue, which is a dead tissue. And those dead tissues, because of the vigorous growth inside the dead tissue cannot expand. So with that, the cells will be opened somewhere else, here and there. Okay, so those openings are called as the lenticels. What we have seen yesterday. What is the difference between the lenticel and the stromatal apparatus? I said. So same lenticels. And these below this is the somewhat simple parenchymatous, and above this is the completely the dead tissue that is present outside this is called as the bark, otherwise the cork. So we will call that one as the phellum. Okay, cork, otherwise the bark tissue is called as the phellum. And the cambial cells that are present during the secondary growth outside the stellar region are called as the cork cambium or else phellogen. And these are having the living, these are the living cells. Cambial cells are always living cells now. So here we have to draw the dense cytoplasm. So that is considered as the living meristematic tissue, when we can easily distinguish from the other cells that are present above and below it. And these are the made up of simple parenchymatous rectangular shaped cells. How they are present? Like this. Cambial cells are always present like this. And what we have to write for the phellogen, otherwise the cork cambium, because it is making the cork tissue, otherwise the bark tissue, we will call this cambial cells as the cork cambium. So how to describe them, how they are present? They are the simple parenchymatous rectangular shaped placed without intercellular spaces. Placed without intercellular spaces. Whenever we are drawing the cambium, the cambial cells should not have the intercellular spaces like the cortex cells, what we will draw. Cortex cells will be having the intercellular spaces in between them. See the intercellular spaces, loosely packed. But here they are the closely packed cells. So we have to draw them like this. Otherwise, we can simply draw the cambium like this also. Whenever we are drawing like this, see, the cells does not have any intercellular spaces, and those are the somewhat thin walled and the thin cells only, not very much large area they won't occupy. Okay, like that only we have to draw the cells in the cambium. So that like the brick arrangement while making a wall. Okay, we are not the workers to make that wall, but we know, isn't it? We have seen at least. So like that only we have to draw. In between the two cells, one cell will be placed. Like that the cambial cells are present. So these are the mandatory sentences for the cambial cells. And these cambial cells are also called as the cork cambium, otherwise phellogen. Okay, because it is having the living nature, and this will make the other cells to divide and redivide. So which cells were made as the division and the redivision over here? The living parenchymatous cells that are present below the cambium and above the cambial cells are going to be dividing and redividing. Okay, so below the cork cambium, the living parenchymatous cortex cells are present now. Those cortex cells will divide and redivide to make the many number of the simple parenchymatous cells. And these cells are loosely arranged. Always the cortex is loosely arranged. And below that, the primary cortex, that is the which is present initially, which was there already. That cortex is present. So this is the primary cortex. And this is the secondary cortex. So primary cortex level is, otherwise the area is very less, only one layer of the primary cortex. So majorly we can see the secondary cortex. So we will call it as the secondary cortex. And this secondary cortex also called as the phelloderm. Phelloderm. That is, it is making the layers in the dicot stem. Those are called as the phelloderm. Okay, so the question is, we are having two questions in that. What is meant by periderm? And next one is the how many layers it was made up of. So periderm is made up of 3 layers: phellum, phellogen, phelloderm. I'm saying the in the specific order how we are looking into the diagram. Okay, and this one, the phellum is the first one, that is the bark, otherwise the cork tissue that was made during the secondary growth by the dead cells. And this one is placed outer side of the dicot stem. And below that is the simple parenchymatous tissue is present, and no need for the any other name for that parenchymatous. And below that is the cambial cells are present, which are meristematic in nature and called as the phellogen, which are making the layer. So we will call it as a phellogen. And this is also called as the cork cambium. And below the cork cambium is the secondary cortex, is also called as the phelloderm, because it's making the layers in the dicot stem itself, which are very, very important and protective one for the dicot stem. So that is called as the phelloderm. If you have drawn this diagram and explained, and that labeling will be on one side and this will be on another side, then only it is very clear for each and everyone who are observing this. Even you can write the points based on this diagram. Okay, always the diagram based questions only. And the next question, what we can see in the 12th chapter in the anatomy is the annual rings. And this question is, during the secondary growth, the many rings are present. Okay, so what is the science that deals with it called as, and what is meant by these rings? Okay, when you cut the stem, we can see the circles. That's the one. So again here, if you draw the diagram, then it will be very good one. When we are drawing on the white page, then how to, which color we need to use, I am saying. Annual rings. Okay, now comes with the color. Which color we have to use for drawing? This is the where we are seeing this annual rings. Once we cut the stem, stem is always brown in color, so we have to use the brown color, and this is not the exact circle. We cannot draw the exact circle, nothing. Why? Because during the secondary growth, the bark is going to be formed, which will be removed somewhere, otherwise opened. So always whenever it is open, it does not have the complete circular nature. No? So that's the one we will draw this outer line with the wavy nature. Because of the presence of the nodes and internodes, we cannot draw the stem as the complete circular one when we have taken the TS of the stem. And that also this after the secondary growth. After the secondary growth, we cannot cut in a with the normal knife, otherwise with the blade. With the sharp, with the machines also, the sharp knife, otherwise a blade, otherwise the saw, isn't it? So here, whenever we are cutting this, we'll get a wavy nature from the outside. And below this also, we have to draw the one more line. And after that, what we have to draw? We will be having the circles. See, like this, whenever you have seen a log, the log looks like this, no? So these are the annual rings. These are the annual rings. So these annual rings, how they formed and what we have to see, and when at which season they have occurred in the plant body. That's the secondary growth actually. This is a complete one topic what now I'm discussing. The previous one, periderm, and this. Okay. So in this, what we have to say, annual rings means 1 year. So in 1 year, how many seasons we will have in the outside weather? That also the specific seasons, autumn and the spring, isn't it? Spring and autumn. In this, which one is the most favorable one for the plant body and which one is not that much favorable for the plant body to grow? These are based on that only we can go with this type of annual rings study. Okay. So the spring season is the most favorable condition for the plant body. How? Because in the spring season, in the outside weather, okay, the temperature is somewhat moderate temperature and moisture will be seen in the outside air and the soil water is plenty of amount of the soil water will be seen under the ground. So that's the plus point for the plants to start their growth, isn't it? They can absorb the maximum amount of water and they can start their growth in the aerial part, that is the stem, leaves, buds, and the flowers, fruits, and everything can be seen. So that is the spring season. What is the autumn season? Autumn season means when in the outside atmosphere, the temperature is somewhat high, then moisture levels will be low. With this, soil water levels will decrease. That's the one what we have to say here. Soil water level decreases. Whenever soil water level decreases, plant growth will not be in a normal way. So here autumn season is not that much suitable for the plant, isn't it? Otherwise, in another way, what we can say for this, it's in that water availability is less. Water availability is less. That's the one what we are saying in the autumn season. Okay. Now we will see how the cells are formed and in which season much more growth can be seen. Even we can say whenever the suitable conditions are there, in that season only more number of cells are formed. Okay. So when the cells are formed, which cells are formed more? So when we are saying the water is absorbed by the plant properly to pump the water for the upper parts to do the photosynthesis, then which part is doing this work and which part has to show the much more growth? Otherwise, the cells has to be somewhat bigger inside. That is nothing but the xylem, isn't it? So in the vascular bundles, that is in the central stellar region, the two tissues are present. There is the xylem and the phloem. So which conducts water and which transports water in the plant body? That is nothing but the xylem. So here xylem develops more because it needs to absorb and pump the water in the upward direction efficiently. Here, the word is the efficient word. So for this efficiency, the cells has to be somewhat bigger in size than the normal cells. So that is the reason why xylem is developed more than the phloem cells during the spring season. Okay. And at this time, how the xylem cells? When we know that xylem is a dead tissue, isn't it? Then why ma'am is saying that that has been grown and showing the big cells? When the dead tissue is there, dead tissue, when there that is a smaller, otherwise a bigger cell, nothing will matter for us, isn't it? But it matters. But it matters over here for the plant body, even for us. Plastic cover is a dead one. It does not have a life. If I'll say I have given you a small plastic bag and I'll say you that in that one put 10 kg worth anything, then can you? No. So the capacity should be more for the bag now. That means somewhat bigger bag I need to give it to you. Otherwise you will scold me in front of me. You may not say anything, but in your brain you will say that how ma'am has given this much, how foolish she is. And she has given a small carry bag and she wants us to get the things of 10 kg worth, whether those are not fit in this bag. So she has to give us somewhat bigger. Otherwise, she has to give us a freelance hand that go and buy that type of bag, which can hold all these things, isn't it? You will get that much of words. So here also same thing I am saying. So the xylem is a dead tissue, but it shows the growth. That means when that is formed, the life will be present, but it is having a very short lifespan for the xylem cells. Whenever those are formed, the meristematic cells are the most important one, which are making the xylem cells. So whenever during the spring season, that also in the spring season will be there. So in the spring season, what are the things that are mostly seen in the air? Moisture is present. Okay. And outside, somewhat moderate temperature, not low. I cannot say low. Moderate temperature. Here I am not writing complete word, temperature. Okay. Temp. And whenever I kept 2 dots in just below the word, means it needs to be read as the temperature. And abundant soil water. Abundant soil water. So these are the 3 things which make the spring season as the most suitable season for the plants to grow, show their growth more. Okay. At that time, what happens in the plant body? When during the spring season, the xylem cells are very long, thin-walled, and the See, see here how the cells are. Those are very long, thin-walled and having a big lumen in them. Lumen means the empty space that is present in the xylem, just like a hole. We are saying in general as a whole, but here we cannot use the word as a whole. Here we have to use the specific word, that is the lumen. Don't think these are the somewhat tough words. We have already learned. If you have not learned, at least learn now. No chance. I cannot say that skip out this word. No. Okay, having a big lumen in them. So through this lumen only, water can be transported very easily. And through the pits that are present in the xylem, that's the another one. But the lumen, why this empty space is present in the xylem? To pump the water efficiently to the upper parts of the plant body. So for that sake here, during the spring season, water availability is more number of xylem cells are formed, and all those cells are long, thin wall having a big lumen in them. Okay. Like this, the xylem is formed, and this type of xylem is the one which is formed in the spring season. It is a favorable condition. Okay. This is the xylem. Now comes during the autumn season. Okay. This also occurs only in the spring season. During the autumn season, how the growth can be seen? During the autumn season, in the outside atmosphere, temperatures are more, less amount of moisture in the air, as well as the soil availability. In the soil, water availability is very, very less. Okay, so these are the three conditions what abrupt the growth, otherwise interrupts the growth of the plant body. The growth will be seen, need to be developed, because plant is the only one organism on earth which shows its complete growth. The complete growth means complete its lifespan till the last day of the death. Till that it will show its growth. That is the plant body. We cannot show that growth. Okay, we may become very fat or thin, that's it, but we cannot show any growth in increasing our length. Mental growth we can show with the age, isn't it? But the plant will show its growth in increasing its height continuously. That is the only one organism on earth. So in this, growth has to be seen, shown in the autumn season also. It says that I cannot show the growth, hands up. No, it will show how it will make the xylem cells in a less number and very thin wall and compactly arranged one above the other. See how the cells are present here. Those are closely, compactly arranged cells which are present with having a thick cell wall in them and a narrow lumen, very thin lumen, narrow lumen in them. So these cannot pump the water efficiently, that much efficiently as these xylem cells can put forward their work to pump the water to the upper parts of the plant body. So this is the autumn season. And this is the spring season growth. See the difference between the spring and the autumn season. So the same difference what we can see in the annual rings also. So here the plant growth affects with the outside seasons. Okay, in one season, in 1 year, 2 seasons are seen where the plant shows effective growth in it. There is a spring and the autumn season. Spring is the most favorable season for the plant body, where the temperature is less and the moisture levels are more, as well as the water availability is more in the soil molecules. So the plant body will show much more growth by increasing the more number of the xylem cells formation, which are long, thin walled. So at that time, the wood that is formed is in a large quantity. Okay. And next comes the autumn season. So this spring won't be there complete 1 year na. After 6 months or 8 months, the autumn season has to come. So whenever the autumn season comes, then the soil water availability less, and the outside atmosphere temperatures are more and less moisture in the air, then growth is retarded. That is the less amount of the growth can be seen in the plant body. Growth is there, but less amount of growth can be seen, having a thick, that is the when we suppress this. See, this is the one. And if I'm going to suppress this, how it looks? It looks very thick now, the tissue. Like that only here, when the cells were congested, it gives a thick cells-like occurrence. So with this only, the rings are having the light color and dark colored rings. So during the growth in 1 year, plant produces the light colored rings and the dark colored rings in them. So the light colored rings are formed during the spring season. So the light color I'm drawing with the yellow so that you can easily see. Okay. So if we count the light colored and the dark colored rings, then we can get the age of the only one rings has to be counted, not both. Okay. If we are counting the dark colored rings, then we can say that is nearby age of the plant body, not exact, nearby age. And if we are counting the light colored rings, only light colored rings need to be counted, because in 1 year, only once the spring season and the second one is the autumn. So during the autumn season, the dark colored rings are going to be produced. Those are the brown colored rings. So with this, in one season, that is in one academic year, 1 year, 1 annual season, then the 2 types of rings are formed in the plant body. That is the dark colored rings and the light colored rings. Okay, so the light colored rings are the spring season and the dark is the autumn. It is the unfavorable. So if we count only one kind of rings, again here the dark colored rings will occur. Again the light colored rings will occur. Like this, light, dark, light, dark, light, dark. So when we count only one kind of rings for in the trunk, tree trunk, otherwise in the log, then we can say the somewhat nearby age of the plant body. Okay, so that is the type of study of the annual rings to say the age of the for the plant body is called as the dendrochronology. The science that deals with this is called as the dendrochronology. Dendrochronology. That means studying of the annual rings that are present in the tree trunk. Otherwise, the log of a tree is called as the dendrochronology. Okay, so with this, we can say the somewhat nearby age. And in this, which one is the most suitable one for the plant body? That means the durability of the wood comes. So whenever we are saying the rings are present like this, in this, the outer one is having the somewhat dead tissue, and whenever this one is occurred like this, then this cannot have the much more durability. Durability is less for this kind of wood that is present outside. So this one can swell up with the moisture that is present in the air, and this cannot be used for making the any instrument. Okay. So heartwood and the sapwood, what we'll say. Sapwood means the wood that is not useful for making the durable furniture. And the heartwood is the one which is useful for making the instruments, otherwise the anything that what will make it furnitures or anything, that is called as the heartwood. Heartwood will be having the much more antibiotics, that means it is having the much more latex, as well as it is having the inbuilt resistance to the microorganisms, okay, and which does not have the water holding capacity in them. So that wood is the heartwood that is present towards the outside. And this one is the bark, which is not at all used. Below that bark is the one which is the most durable wood, and this wood is the one which does not have that much of durability, and it will be used for making the small things in our residential areas, okay, which does not have the much more durability. So the heartwood and the sapwood, like this also we can divide the wood. If you remember this word, then you can write. If not, no need. You can say this one only. So what are annual rings? And when we cut a stem, when we cut a tree, the log is showing the much more circles, otherwise the rings in them. What is that? Okay, what the question? So in that, what we have to say, the rings that are occurred by after cutting a tree are called as the annual rings. Annual rings are formed in the plant body by the seasonal growth. That is in 1 year, 2 seasons will be there. In that season, the growth can be seen by showing by this we can see the rings that are formed in the log of the stem itself. So in that, one is the dark colored rings and the light colored rings. Dark colored rings are formed during the unfavorable season, that is the autumn season, and the light colored rings are formed by during the favorable condition, that is the spring season. In the spring season, the water availability is more in the soil, as well as less temperature and the high humidity. Otherwise, the water vapor will be more in the outside air, so that it makes the plants to grow in a proper way, otherwise more in the quantity also. So the wood that is formed during the spring season is more than the wood that is formed during the autumn season. And in the autumn season is the one which is the unfavorable condition for the plant body, because lack of availability of the soil water and much more heat will be there in the outside weather, and the moisture levels are very less in the air. So this leads to the less growth in the plant body, so that the xylem cells are made very compactly and gives the dark colored ring-like occurrence in the annual rings. So by counting the dark colored rings, otherwise the light colored rings, we can say somewhat nearby age of the plant body. So this type of science which gives us the facility to study the rings and give the age of the plant body is called as the dendrochronology. With this, we can wind up this answer. And now comes the next one. That is how the epidermal cells are, what are the cells that are present surrounding the stomatal apparatus differs from the subsidiary cells. Otherwise, the living cells that are present outside the God cells, what is the name? Okay. Living cells present outside the God cells. Okay. Name the living cells. Name the living cells present outside the God cells and how they differ from the epidermal cells. How they differ from epidermal cells. And show this with the diagram. What they will ask is show this with the diagram. So here what they ask, the cells that are present outside the God cells, name them and how they differ from the epidermal cells. So the God cells, whenever that comes over there, that is they are talking about the stomatal apparatus right now. So first of all, we will come to the conclusion that it's nothing but the stomata. Okay, then the stomatal cells, where the stomata are present, the stomata are present in the leaf, isn't it? And that also, these are formed by the epidermal cells of the leaf. And what are the parts of the stomata? Stomata is having the God cells, subsidiary cells, and stoma, nucleus, chloroplast. These are the ones what we have to after this, what I need to draw. In this also, nucleus. And this also nucleus. So now we will start giving the labeling part. This is the stomata. Okay. So in the stomata, in the center, we will start. This is the stoma. There is a opening in the stomatal apparatus. And these are the bean-shaped cells are the God cells. And the cells that are present surrounding the God cells are called as the subsidiary cells. Okay. And in the God cells, these are the chloroplasts. And this is nucleus. Okay. So what we are saying now, the cells, name the cells that are present surrounding the God cells. Surrounding the God cells are the simple parenchymatous or somewhat large cells are present. Those are called as the subsidiary cells. Okay. And these subsidiary cells, the God cells are completely made up of the epidermal cells from the epidermis of the leaf. And these are meant to store the much more amount of the food material and the water that is going to be, has to be evaporated, otherwise need to be supplied for the God cells. And both the cells are having the clear nucleus, that means the God cells and the subsidiary cells, both are having the clear nucleus and the cytoplasm. And this is the cytoplasm in it. And both are having the chloroplast in it. And the God cells are having the bean-shaped God cells in the dicot plants and the dumbbell-shaped God cells in the monocot plants. Like this, the God cells are present in the monocot leaf. So this much we have to draw, we have to say, and we have to draw the diagram. And the God cells are having the somewhat thicker cell wall towards the inside and thin cell wall towards the outside. This helps out in the opening and closing of the stomatal apparatus. And the small opening, that is a narrow opening that is present in between the two God cells, is called as the stoma. That is this gap, okay, called as the stoma. Now comes so what they asked in the question, how those are differs from the epidermal cells. Epidermal cells are thin-walled parenchymatous rectangular shaped cells placed without intercellular spaces. This is the sentence I was keep on saying the same thing since 3 days, isn't it? If you have seen, you have joined only for today's class, just go through the previous classes also. I used to say the epidermis is made up of simple parenchymatous rectangular shaped cells placed without intercellular spaces. And for the subsidiary cells, I didn't set that word, isn't it? They are not the rectangular. They are somewhat bigger sized cells having thin wall, but bigger in size. So that's the difference between the epidermis and the subsidiary cells. And the subsidiary cells are surrounding the God cells, which will give the much more amount of the water for the God cells, otherwise support for the God cells to be protected for the opening and the closing of the stomatal apparatus. But the epidermis is not for that. Epidermis is the protective layer for the entire part of the leaf, otherwise the monocot stem. So epidermal cells are always gives the protection for the stem or the leaf from the outside atmosphere, and these are placed without intercellular spaces. In the subsidiary cells, intercellular spaces can be seen. Those are the somewhat bigger in size. See, those are not the rectangular. So we cannot say that both are the same. Both are parenchymatous, but not like the same. Functions are also not same. That's the one what we have to write, and we have to end up, and we have to draw the diagram for the stomata, and for the epidermal cells, we can draw the diagram like this. Like this also we can draw the epidermal cells. Okay. So with this, we have finished all the questions. There is a possible questions from the 12th chapter. So with this, we have finished the SAQs from the 13th chapter, ecology, and the 12th chapter, that is the anatomy. From these two chapters, one SAQ is mandatory. Lock kar diya jaye. ABC, lock kar diya jaye. So out of 8, 2 questions mandatory from these 2 chapters. If you prepare thoroughly, then it's only benefit for you, not for me. So start getting the benefit by reading the subject thoroughly. Okay, every time if you keep on reading the chapters, only 6 chapters I'll give. So that 6 SAQs you can write and you can get the good score, and the passing marks are also coming with this. Okay, so start reading these 2 chapters thoroughly along with the VSAQs, because what now we have covered is the VSAQs are also covered in the SAQs. But from the 12th chapter, we won't get any VSAQ, only SAQ and the LAQ. Okay, so for the 13th chapter, VSAQs and the SAQs. VSAQs are only 6 VSAQs. You can easily prepare what I said, this same one in the VSAQs also. So prepare from the VSAQs and the SAQs, and we will meet for the botany first year class, same time, same channel. Okay, stay tuned to the same channel, right? Thank you.